Okay, so I'm assuming that you can see my screen, and the first thing that we are going to talk about today is simply that, for example, you are doing a data science experiment or you are doing a data science project, and you got handle of certain data set. So maybe a customer gave you a data set, and now you are taking a look at the data set for the very first time. Now, you must have seen a lot of YouTube videos in which people are doing a data science project in 2 hours, in 1 hours. In reality, in reality, that is not an ideal timeline. So what happens is, in reality, you have to spend a lot of time in several different small things. For example, like understanding each individual feature. So if you have a data set which has a lot of features, when we talk about features, we talk about columns. So if you have a lot of columns in your data set, then you have to take a look at every individual column and extract some information about it. Maybe the univariate analysis you have to do separately, then multivariate analysis you have to do, means and things like that. Then there are certain other things which come into play. For example, you have to check for outliers, you have to handle missing values, you have to do encoding, you have to kind of like do a lot of stuff. And there are sometimes some columns which kind of like tell you the same story. You can merge them up somehow, or feature engineering or feature selection comes into play. All those things are basically come under the umbrella of you can say exploratory data, exploratory data analysis. Now there are so many different names which people use for this particular process. People also call it data pre-processing. So pre-processing means it is the processing that you need before you put your data into the model. And it is also called feature engineering. So feature engineering. Now, a lot of people kind of like talk about these things, and these things overlap, which means based on the definition, if anybody is defining exploratory data analysis, data pre-processing, and feature engineering, a lot of steps overlap, a lot of things you have to do in multiple different scenarios. So there is not a clear cut definition for these particular categories of processes that you do on your data set. But what we're going to do is we're going to assume that we are doing data pre-processing right now. And in the data pre-processing, what I do is, first thing I do is basically take a look at the data set and get a feel of a data set. And then the first thing that I start is handling missing variables or handling missing data. Now, before we get to that particular point, we need to understand one important thing. For example, there are several different mechanisms how the data is missing. We need to understand that. Okay, so we need to understand that. So everyone's good so far. Okay, so we need to understand that. Now, there are three different mechanisms that are highlighted here. So the first one is missing completely at random. In short, we also call it MCAR or MCAR. Then the second category is missing at random. And the third category is sometimes called not missing at random, or sometimes it is also called missing not at random. So in some textbook, you're going to see it as MNAR, MNAR, or sometimes you're going to see it as NMAR. Now, what exactly these mechanisms are? Let's understand it. So I have gathered, means I have written, means this is technically one of my posts that I wrote on LinkedIn. And what I talked about is I gave few examples here. So I'm going to read out these examples and I'm going to talk about these examples so that you get an idea what these mechanisms are and why knowing these mechanisms is important. So first thing first, when we talk about is anchor is unobserved data. So for example, what we are doing is we are taking an example, and in this particular example, what we are doing is when we take a random sample from a population, let's say you have a huge population of certain people, and out of that population, you grab some people as a sample which is representing that population randomly. So what you do is each member has an equal chance of being selected. So whenever you have a population and you are selecting people in such a way that every person of that population has an equal chance of getting picked up, that is when we say that the situation has. So for example, if any of the people who were not picked up, those people are considered that they are missing completely at random. That means why they are not part of the sample, because they are completely randomly missing from the data set. So that is a simple basic example of how data can be missing. So this is the most easiest mechanism, and to deal with this mechanism is the easiest way. And how to deal with it? It's pretty straightforward. Since it is randomly sampled, you can just ignore those values, and there are some strategies we are going to talk about. So this is the easiest mechanism to handle it. Okay, so then there are some other mechanisms. So let's talk about the second one, which is when the data is missing at random. So what is the difference between completely at random and simply at random? So this is where the example comes into play, something like this. When we pick a sample, so the same population you have it, and you are picking a sample again, and the likelihood of inclusion is determined by some known property. For example, you have a total population, you have equal number of males and females, but you are picking more females than males. That means the data that is missing, for example, men are less represented in your data set. And that is where the example here is why the data for the men is missing or less number, because it is missing at random, not completely at random. So, for example, like you are collecting data, you are getting your same samples from different stores. For example, like you are going to stores where women like to shop more than men. And if you are going to those places, you're going to find more women. And if you're going to find more women, that means you're going to take sample from more women than men. So that is technically one of the bias. So there are certain other things we usually tell them that there are biases. Right now, I'm not going to talk about different types of bias. I'm going to cover that in a separate lesson or separate lecture later. So there are so many different types of biases, and we're going to talk about them. That what kind of biases can um, 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 be part of the data, and they influence how the data is missing, and you can get some extra information about it. So, uh, okay. So now let's talk about the third category. Third category is the most easiest one. It is the opposite of this one. So what was happening over here? We were saying that it is completely random. That means every person has an equal chance of getting picked up. But when I say missing not at random, that means every person has not equal chance of getting picked up, which means this one is the most straightforward one in this particular scenario. As you can see, when we pick a sample from the population that is not representative of overall population. For example, you are just going and asking people of minority from a very big population. That means those people are representing very small amount of the total population. And if you're going to ask only that population, you are not collecting all the information. So you are missing out some information, and that missingness is because you are not kind of like that data is not kind of like missing at random. It is not missing at random. So the other way is, for example, if you have a population where different particular ethnicity of people are being represented, and for some reason you are not including some of the ethnicities in your study for some reason. Maybe you don't have access to those people. For example, you are living in an area where you don't find some people of different ethnicity, and that is the reason why you don't bother to go to different places to include them in your data set. And when you miss those particular data points, that means you are missing things not at randomly, because there is some sort of a bias here, and that's why this particular missingness is not at random. Not even simple not at random, completely at random, it is not at random. So these are three different mechanisms. Why exactly we are studying these three mechanisms? Because handling data depending on which mechanism, through which mechanism we don't have the data, or what is the missingness in our data, part of which mechanism, that tells us which particular method we are going to use in order to handle the missing values. So that is a very, very, very important thing. Understanding these mechanisms is very important. So when you are doing data analysis, or when you are doing data pre-processing, the best way to do is it one column at a time. You take one column and do all the analysis on that column. Make a brief summary about it, that what kind of a distribution it is showing, what kind of randomness or missingness it has, which particular whether the data is missing in that column at random, completely at random, not at random. Then you talk about whether the data is skewed, whether it is on the right side, on the left hand side, what was the kurtosis or different statistics, what was the variance, what was the mean value, what was the median, what was the mode, or how many frequent values were there. So you get information about every single column. And I'm going to tell you, when you go to big companies which have huge amount of data, there are some companies which kind of like, so when you work there, what you're going to do is you will be only responsible for certain features in the data set, not all the features, which means it's your responsibility to take care of those features and keep track of changes that are happening in those features. Because when we talk about model tracking, when we talk about deployment, everything, so when you deploy a model, as the data keeps on coming, the model needs to be updated. Some features change their distribution, and you need to keep track of it. And when you have a lot of data, very big data, what happens is there are people who are responsible for certain columns, and then there are people who are responsible for other columns and other columns. So, for example, if I have, you can say 500 columns, 100 columns would be responsibility of one data scientist. The other 101 would be for the other one, and the other one for 100 for the other one. So usually that is the case. That is how practically things happen. You cannot finish in real life a real life project in 2 hours or in 1 hour, as you have seen people doing it in on YouTube. So I'm also on YouTube right now, but I don't like to do that. If I start making, means for just for the sake of making videos, I can make hundreds of projects videos, and those videos are kind of like they get a lot of hits. And I know the formula means of YouTube, means if I want to just make videos and get more subscribers and everything, I can do that. I'm not doing it because that is not the right thing to teach. If I want to do something, I'm going to do the way it is being done and the way it's going to help you, and not just kind of like following the trend that, oh, just make these project videos and you're gonna have a very good time on YouTube and you will get a lot of subscribers and a lot of watch time and things like that. I don't care about watch time. Yes, I care about watch time. It matters because I'm putting in some effort, and if people are watching it and getting benefit from it, that is my motivation. I get motivated from that. But my motivation is not that I will have this many subscribers or this many watch hours and everything. If 10 people are watching it and they are benefiting from it, I'm happy. So that is my goal. So how to choose the method? Let's talk about it. Now, when we talk about choosing the method, now let me break it down into different strategies. So, first of all, when let's say I have a data, let me change the color maybe here. So let's say I have data, and that data has some missing values. The first possible way is you can remove the missing value. So you have missing data. So when you have missing data in your data set, the first and most easiest thing that you can do is remove all the columns, or you can say remove all the rows which have some missing data. That is the most easiest strategy you can do. If you have billions of instances and um, maybe 2% of the data is missing, it's better to just get rid of it and you will save a lot of trouble there. But we're going to talk about it. So when you do this particular step, which means this is also called complete case analysis. And that is what I'm gonna break down today. So, what that is, I'm gonna talk about it right now. Let's move on. So, this is one way to do it. Then the other way is you can impute the data. So, you can do imputing. So, you can do some sort of imputation. And now, when we talk about imputation, imputation can be divided into two different categories: univariate, and the second one is multivariate. Now, when we talk about univariate analysis, so univariate analysis is different for numerical columns, and it is different for categorical. So if I have a numerical column which has some values missing, I have to do means I can apply several different strategies which will be different for categorical columns. So for numerical columns, what you can do is the most simple one using sklearn library. What you can do is you can use simple imputer from it. That is one way to do it. Or from pandas, what you can do is you can use fill na. These two things or these two methods that you can use from two different libraries. And that is what we do for univariate. So what exactly is univariate? Univariate means you don't look at all the other columns. If one column has some missing values, you look at only that column and no other column whatsoever, which means changing the values or filling the values in that particular column is not influenced by any other column other than that specific column. When that happens, we call it univariate imputation. For numerical, we usually, what we do is the easiest thing, a lot of projects you must have seen on YouTube, what people do is they change all the missing value with the mean of the data or mean of the column or the median of the column. These are two things that they can do or you can do. The other thing that you can do is you can fill it with a random number. any number which is not part of your original data set, which means you pick a number randomly which is not part of your original data set, and you can replace it with a random value or arbitrary. This is also called arbitrary value. And then another way is basically you can pick a number specifically. For example, if you have a data distribution like a bell curve like this, so you pick a value either at the end of this side of the distribution or at the end of this side of the distribution. So, which means we can pick numbers or random numbers at the end of distribution. We are going to talk about all of these strategies, and I'm going to show you by coding on a real data set, which you have kind of like not seen very often on the internet. So this is a new data set, you can say. Yes, that data set is out there for a while, but not many people have used it yet. So which means it is something, if you start working on it, you will have a very unique data set that you have worked on, and you can showcase a very good portfolio project using that particular data set. And what I'm going to do is I'm going to stick with one data set and do all those techniques on that data set, and I'm going to show you a complete end-to-end project on that particular data set. And which means by the end of these sessions, when I'm going to be ending these sessions, we will have a one complete end-to-end project with so much detail in it. That means if you start accumulating all the notebooks for that, you will have a portfolio worthy project. Okay. So um, everyone is good so far. Anybody has any questions? Please ask me. Um, if we are good, then I will continue on. And if anybody has any questions right now, stop me, ask me a question. I'm going to address the question, then I'm going to move forward. So, so write down in the chat if you're good, if you have any questions or not, so that I can interact, because this is the first time I'm doing on YouTube live streaming. It's not easy for me to kind of like interact. Um, okay, so if you're good, then what we can do is we can do one simple thing. So for categorical variables, let me just erase it and so for categorical variable, what are the strategies? Variables. The strategies, when we talk about those strategies are basically, instead of mean and median, you replace the missing value with the mode of the data. And what is the mode? It is the most frequent value in the column. That is what you can replace it with. And then the other thing that you can do is you can make a new category and you can name it missing. For example, all the missing value, all the missing data, you create those missing values or fill those missing values with a new category name as a missing name. So which means whenever you're gonna look at that, you have, for example, like um, um, when we talk about, for example, like road conditions, they were wet, they were damp, they were dry, and in some cases you don't have the data for the road conditions that particular day, and it would be nan value or null value. So what I'm gonna do is I will replace that null value with missing. That means this way I'm adding a new category which will be useful in some scenarios, because keep one thing in mind. If you remove all the missing data from your data set, that means when you are deploying your model is not trained to handle missing values. So keep one thing in mind, that removing all the missing data is not ideal, because the model that you are training is not trained on handling missing data. So you need to be very careful about that. So if you are using some tree methods or things like that, they can take care of extra categories like this very easily. So the good way is, instead of removing, just create a new category missing, and your model is gonna be kind of like very robust about it. So this is what we can do for categorical. Now, what about multivariate? For multivariate, I'm going to talk about, there are so many different ways you can do it. The one way I'm going to talk about is KNN imputation. I'm going to break down. So whatever all things that I'm talking about here, I'm going to break down the background mathematics. I'm going to break down the background statistics, and I will explain basic, simple definitions of it and what they are, and how they are used in our data analysis. And I'm going to break it down. I'm going to break down the mathematics as well. The mathematics in KNN imputation that is used is mathematics that we use here is, you must have learned it in grade 7 or grade 8. So it is simply a distance formula. We are going to start with the simple basic Euclidean distance formula, but there are so many different other distances that we can use when we get to use sklearn. Sklearn provide us several different data, the distance measures for k-NN imputation we can use. But I'm going to explain you the simple basic one, the Euclidean one, and you're going to see that it is pretty straightforward technically. And if you apply k-NN imputation on a very huge data set, it's going to take a lot of time, and you will understand why the computation is so heavy when you are applying k-NN imputation on a very huge data set. And the second thing that I'm going to talk about, or the second different type or method to treat missing values using multivariate imputation is iterative imputation. This iterative imputation is also called mice. So this mice is a means it has a name. Means what is the name? We can quickly search about it. So what I can do is I can search about it. Mice imputation. What exactly do we call it? I forgot about the name. So MICE is basically multiple imputation method. So it stands for multiple imputation by chain equations. So it is kind of like an iterative process, and I'm going to show you the mathematics behind it, and I'm going to pick a very small data set, and on which I'm going to show you step by step what happens in step 1, what happens in iteration number 2, what happens in iteration number 3, and what happens in iteration number 4, and how your data is getting or missing values which you are filling using those iterations are getting better and better and better every iteration. So more iteration you're going to do, the closer you're going to get to not the real value, but the accurate your prediction will be. So that is the whole gist of it. So all of these things, when I talk about all of these things, we're going to cover that in our next sessions. In this particular session, I'm going to talk about complete case analysis, because this is the first one, this is the easiest one. Let's start with that one. Okay, so let's start with that one. So I'm going to start with complete case analysis. So let me write down complete case analysis. Now, first of all, let's talk about assumptions for complete case analysis. So when I talk about assumptions, what exactly are the things that we need? So when to do complete case analysis? The first assumption is your data should have missing completely at random. So this mechanism, so you don't have data because of this particular mechanism. So remember the three mechanisms that we studied. Why? What was the reason we studied them? Because the first assumption, if it is first mechanism, second mechanism, or third mechanism, based on that, your strategy is going to change. So if your data is missing completely at random, that's when you will use complete case analysis and it will be reasonable to use it. But that is not the first assumption. And the second assumption is you have a very small amount of missing data. So when I say small amount, that means very small percentage, less than maybe 5%. So this number is kind of like based on your experience, depending on your use case, depending on how much data you have, this number keeps on changing. So small amount of missing values. So these are the two assumptions for complete case analysis. Okay. Now, one important thing, another thing. So, uh, yes, Rafael, you were asking about distribution method in numerical imputation. I'm going to talk about all of them. Right now, I just gave the names for these methods. I'm going to start talking about every method one by one. So right now I'm talking about complete case analysis, and in today's session I'm going to talk about complete case analysis, and I'm going to show you doing coding that how complete case analysis we usually perform, and column by column. Okay. In the next session, I'm going to cover simple imputation of numerical, where I'm going to talk about everything related to numerical variables. For example, like if you have numerical variables, I'm going to, so this session is this one. So this is session one. I'm covering it. This is what I'm going to cover in session number two. And this one and KNN imputation, these two things together, I'm going to cover in session number three. And this iterative imputation is a pretty big one. So that's why I'm going to cover that in session number four. So today is Wednesday, November 9. We are covering it this particular session. Friday, we are going to do this one. Monday, we are going to do this one. And then next Wednesday, we are going to do this one, which means in 4 sessions, we will cover every single thing. And let me tell you one important thing. If you go and find different books about it, technically we are covering half a book, uh, because we are covering all the mathematics, we are covering the coding part, we are covering the intuition part. So we are covering every bit of it, which means once we finish these sessions, you don't have to go and spend your money on buying some Udemy or Udacity or edX or Coursera courses. You can always come back and you can always watch these sessions. And these sessions are basically, and one important thing, it's not like I'm gonna just do all the work myself. I will assign you some data sets that you can apply whatever we have learned in the session. You can apply them in a different data set, which means whatever I'm doing, you can pick another data set and you can apply on it and do your analysis. And this way, what's going to happen? You will learn the process of how to do it yourself on any data set. Okay. So I will give you some easy data sets. I will give you some. I will share with you with some tough data set, and by applying the same thing, which means the notebook that I'm going to share with you. All of you can right now see in the description of this video that I have shared a notebook as well. I have shared the data set as well. So the notebook that I'm going to use for today, It is already available. If you want, you can download it. You can download the data set, and when I would be doing coding, you can do it beside me. Okay, and along with that, what I would be doing is I would also be assigning you some data set that you can download, and you can apply whatever we have done in our data set. You can apply it on different data sets, and you will get a good practice on everything that we have learned. Okay, so keep one thing in mind: doing projects in 1 day or 2 day, 1 hour, 2 hour is nothing. You are not going to learn anything there. Okay, for example, those projects only work if you have an interview lined up, and you want to prepare a notebook just to show your interviewer that you can learn things quickly or something like that, or you can say that, oh, since my interview is in a particular company which works on a particular kind of a data set, that means you can grab that kind of a data set and you can watch a video about it, and you can make a project about it and do some tweaking in it, and this way you can have your own project which you can talk about during the interview process. But keep one thing in mind: that is always the case when you know how to explain it, because watching just 2 hour video and 1 hour video and completing the code, you don't learn as much. You cannot explain in that much detail about that particular project. And if any experienced person is asking you a question about it, they can simply figure it out that you just copied it. You did not do it yourself. So doing projects yourself is going to make you a better data scientist and data analyst. So keep this thing in mind. Okay. So yes. So Lavanya, you were asking me, will all of these sessions would be this time? Yes, they would be this time. So I'm in Toronto right now. This is very early morning for me, because when I announced it, uh, so when I announced these sessions, a lot of people who said that they will be willing to watch this session, or they're interested in this session, those people were kind of like in those time zones where if I do a lesson at my reasonable time, they won't be able to watch it, or they won't be able to attend it. So I'm doing it at a time where it would be their afternoon, and maybe if they get time, they can jump in. Means it would not be an odd time for them. So that's why, since majority of the people who said that they're interested, they were in those time zones where this 5 a.m. for me did work. Means I cannot do more later than that. Means I know that for them it would be, for example, like majority of the people were in Europe, maybe, or major some people were in India, some people were in Pakistan, and some people in African region. So their timing was kind of like totally different. Means when it is night for me, it is day for you, and things like that. So 5 a.m. usually is my morning, a very early morning. So I usually get up at that time. So I thought maybe why not, and this time would work for you. So in India, I think it is 4 p.m. Yes. So does that time work for you? So, so how many of you are good with this timing? So this timing works for you? Okay, sounds good. So, um, and I know that this is my first time doing a streaming on YouTube. I don't know how much sound feels like, because I don't have different tools. Means I don't have mic or things like that. I'm just using my webcam and mic. I don't know what kind of a noise you are hearing, or whether it is loud or not, or things like that. So after the first stream, my next stream would be better, because then I would be able to see what exactly have recorded, and what kind of like went through. So based on that, I can adjust the next time. So this is something I'm learning as well. So just stick with me. Okay, so if this timing is perfect, then that's amazing. Let's continue this session. What I'm going to do is I'm going to talk about complete case analysis. And in complete case analysis, I've already started talking about these assumptions. And when I talk about these assumptions, the next thing I'm talking about is advantages. So, what are the advantages of complete case analysis? Remember, when we talk about complete case analysis, what it means is we are removing all the missing data. That means we are only taking a look at the data which is complete. So that is the reason why we call it complete case analysis. Okay. So technically, complete case analysis means removing all the missing data. So when we talk about advantages, it is pretty straightforward, easy to implement. Means remove, means you just need to kind of like drop any. That is a command that you're going to use, and you're done. Means you just did the complete case analysis. So easy to implement. That is the best advantage it has. And then one important thing, it preserves. So it preserves the distribution of data, because keep one thing in mind. If you have very small amount of missing values, let's say less than 5%, removing those missing values would not change the overall distribution as much, because you still have 95% of the data. Okay, so which means it preserves the distribution of data, or the column. And this is what you have to do. For example, in some cases, you won't be able to figure out, oh, whether this particular value or this particular column has missing values. Is it because they are missing completely at random or not? Because this is a very unrealistic case. Majority of the time, there are biasness involved, and those biasness never give you this particular case. So this case is a very rare one. Majority of the time, you will find missing values at random or missing values not at random. So, which means this case would occur very rarely. And if you have less than 5%, you can still apply it, because then you need to take a look at the distribution. If the distribution of the data is changing because of dropping these values, then don't do it. And if the distribution is not changing, then do it. Go ahead and do it. Okay. So these are a few things you need to keep in mind. So so these are the advantages. Now, definitely it has some disadvantages as well. Let's talk about these disadvantages as well. So when I talk about these disadvantages, the very first one is it can exclude, means if you are not careful, if you are not looking at this 5% data, which means if you are dropping all the missing values, if you have 50% missing values, you're gonna lose 50% of the data set. So you can drop um, a lot of uh, key or valuable data. That is one of the disadvantage, which means you cannot apply it if data is missing with higher percentage. Which means if you apply, if you check which column has how many percentage of data missing, you can apply it on few of the columns, not all of the columns. Okay, which means if the columns have missing data more than 5%, then you have to apply some other technique. Okay, so complete case analysis would not work. The second thing that it has is it excludes observations can be informative. So excluded observations, um, they can be informative, which means even if you are losing that 5% of data, the data that you are losing, maybe that data is valuable for the model. So excluded observations can be valuable, which means you can lose a valuable information, even though you are dropping just 5%, but you are dropping some valuable information, okay, which can influence the overall model building process. And then third thing is in production, you don't have the model which can handle missing values. For example, if you have several different columns, and out of those columns, for example, like when you trained your model, you had all the data available. So because you were doing a complete case analysis, you dropped all the values which were missing. But during deployment and during production phase, you are testing your model on new data. And if that new data has missing values, for example, this value is there and this one is missing, this one is missing, your model is not trained how to handle these missing values now, because you cleaned your data so well and you trained your model on such a clean data that if your new data does not have few things as close to what your original data was, your model is gonna throw garbage out. So keep that thing in mind. So this is one of the disadvantage, that in production, model will not know how to handle uh, missing data, or what to do with the missing data. Okay. Now, uh, when to use it? Let's summarize it. So when to use complete case analysis? When we talk about this, it's pretty simple. First of all, these assumptions are the two things that I need to keep in mind. If my data is missing completely at random, then I'm going to use it. And if the data is less than 5%, at least. So 5% never go above 5%, but below 5% sometimes in some cases. Um, 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 um. For example, if you have just 100 data points, you are missing 5, which means you are losing 5 data points and you are left with only 95 data points, which means those 5 are more valuable in this scenario as compared to if you have kind of like 1 million data set and then you are losing 5% of it. That means you have still thousands of data. But in that scenario, 5% can can do well. But you have to check and try. The less amount of data you miss or get rid of, the better you are. Okay, so your goal should be to not drop anything unnecessarily, because what you are doing is you are excluding some observations which can be valuable. So you always try to preserve the value, because data is very costly. Data is very scarce in certain scenarios, so you have to be very careful with that data that you have. Okay, so if you're making some projects or things like that, means if you open up your notebooks during interview processes and you are showing that, oh, this is the project I did, and the interviewer is asking you to explain the project, and you start explaining the project that, oh, got the data from Kaggle, let's say, and then I started doing data analysis, and I came to this part where my data had a lot of things missing, and you're going to talk about, oh, how did you handle missing data? What you did is you just simply applied simple imputation and you replaced everything with the mean. Everything, without even going and taking a look at these assumptions and things like that. And that only works on YouTube. That only works on for tutorial purposes. Because in tutorial, if everybody starts doing all these techniques on just handling missing values, then that project is not going to finish in 1 hour or 2 hours. So you can see that this particular session has been going on for 50 minutes now, and I'm just talking about one technique right now. Okay, so which means if I start talking about all the techniques, my project is going to be too long, and that is the reason why doing one project, which takes 2 months of your time, is considered a portfolio worthy project. Okay, 2 hour long project is not a portfolio worthy project, because yes, it looks good, means just for the resume purposes and everything, just to showcase it, it's good. But when you start explaining it, or when you start opening it in front of interviewers and showing them to interviewers and explaining them to interviewers that, oh, this is the project I did, and these are the things I did, and then they're going to ask you questions. Why did you apply just mean imputation? Why did you not try anything else? Did you see which mechanisms every column was? Why did you handle every column exactly the same way? Because maybe some column requires a different handling technique than the other one. So you have to be very careful about it. Okay. And even if you did 2 hour projects in that particular scenario, if you know this stuff, you can talk about it on the spot. That, oh, I was doing to showcase it to you, and that's why I kind of like skipped all those things. But I know that I need to be careful about these mechanisms, and I need to be careful about these assumptions, and I should be careful about that. But since it was just to show you that I'm capable of doing things on the go very quickly, I just summarize it using just one single technique instead of applying all the techniques. So you can turn it around if you know the theory well. Okay, so this is something you have to be very intelligent about, and very careful about. Now, so this is the theoretical part. Now let's get to the coding part. Okay, so when I get to the coding part, I'm gonna open it somewhere here. So what I have done is, first of all, let me show you that. So what I'm doing, all these sessions that I'm recording, and I'm doing it on YouTube. What I'm gonna do is, I'm gonna be putting it on my GitHub, and you can see this is the first one, first session, where so this particular link has been provided to you on the streaming platform. I don't know where it is. Uh, so it is on the streaming platform, which you can use. Let me open it. So maybe. So if you go in the description of this particular video, you're gonna see one important thing. So this link, I have already shared it with you. Okay. So if you open this particular link, this link is gonna take you to this particular GitHub channel. So that particular link is going to take you to here. This is the link for the dataset. So all of you who are already taking this project on Amdena with the Rich, so you know that the dataset is pretty big, and that dataset was not, we were not able to upload it on GitHub. So what I did is basically I put it on Kaggle, because Kaggle gives you about 109 GB or about 200 GB of data that you can put on, which means you have a lot of so I can put that. So this data set is now on Kaggle, you can use it. And I know that a lot of you have made a lot of notebooks for the project, and I would recommend you go and use that data set and upload your notebooks for that particular data set. So this is the data set over here, and you can use this data set and you can upload your notebooks here, and these notebooks are going to be displayed down here somewhere. So top contributor, so if you are making some notebooks using this data set, you will have some top contributors somewhere here. Okay, and what you can do is you can ask around among your teammates, and you can get some upvotes on it as well. Okay, and I would recommend you support each other in this particular scenario. If you like that particular video, you benefited from it, then give upvotes. And even if this particular data set that I'm showing you, since you have used it and everything, give it an upvote. Okay, so yes, the approach of beginners or novices does not count, but still, even if you are a novice, just give it a thumbs up, or technically it is called approach on Kaggle. So those approach does matter, and they will kind of like you can start displaying these notebooks to your employers as well. So those notebooks are not just for you only. If even if you are not getting any approach, you can put them on Kaggle, because Kaggle gives you a lot of memory to put a lot of big notebooks and big data sets and everything. So if GitHub is not allowing you the free version of it, then put it on Kaggle. And on Kaggle, I would recommend you keep all your notebooks on Kaggle. Maybe somebody would like it and somebody would give you an upvote, and few upvotes can give you some medals, and those medals are gonna make you Kaggle expert or things like that. And becoming Kaggle expert or Kaggle kind of like contributor is pretty straightforward. Okay, so getting few and write some comments on some people's post, give some value to them, and you're gonna get some medals. Means on you can say discussions, you just need one upvote to get a bronze medal, which means go and every day make a mindset about it, that go and give 10 comments back to someone with some value. And maybe out of those 10 people, 2 people will upvote it. That means you got 2 bronze medals in a day, by writing just 10 minutes of answers helping people out. So I would recommend you guys start doing that. And so this notebook is already there. So I'm going to open the notebook now, and I'm going to go through with the I'm going to go through the notebook with you. So first thing first, what I'm doing is I'm importing all the libraries. uh, Now you must be asking that, oh, these 3 libraries does make sense. Then what is the need of what exactly I'm doing here? So this line is handy if you are kind of like using some other IDE like PyCharm or something like that. Because in Jupyter Notebook, your kind of like figures are automatically rendered. But if you don't write this line in different IDEs like Visual Studio Code or something, or PyCharm, they do not get renders. So they can be shown within the line. So if you don't want to use it in the Jupyter Notebook, you can still get the same result. But if you're not using Jupyter Notebook, then it is a good idea to write. Then some of the uh, tools that we use, for example, like they are deprecated and everything, they start showing some sort of an error. So what I did is basically I ignore all the errors, because I don't want errors on my notebook. Okay. So then what I'm doing is basically when you means kind of like read a data set and try to open it, what happens is, for example, if I don't show maximum column, what it's going to do is, it's basically when I read my data set would have something like this. So my data set right now, you can see, I can see all the columns. But if I did not do this particular line, I would be getting some dot 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 somewhere in the middle here. Okay, I would be getting those dot dot dot. For example, maybe this is a sheet where I did that previously, and if I did it here, you can see over here, I'm not able to see all of it. You can see these dot dot dots, which means not all the columns are visible. And I want to see all the columns. So what is a good way to do it is basically simply just writing this, that pandas set options display maximum columns, common none. Okay, what that is, you can just go and put it on pandas documentation, and you can read what variables or what parameter is doing what. Okay, and similarly I also did with the rows as well, because when you do, for example, like summary statistics, or when you are looking at how many categories every column has, so it will not show you all the rows, it will show you some dot dot, and it will skip some rows in the middle. And in order to show all the rows, I did that. So this is usually what I do at the beginning of every notebook. This kind of like gives me access to every row and every column whenever I want. Okay. Then the next thing what I did is how to input data. So I don't need to download data because what I'm doing is this is my data set. So what I do is basically you open this data set. So if you are logged in, what you can do is you can start a new notebook here. So when you start a new notebook, that means in this particular new notebook, it's going to create a new notebook. You can name it whatever you want. And then one important thing that you're going to see here is the data is going to be already uploaded for you here, which means you don't need to download data if you are accessing or starting the notebook from that dataset page. Your dataset would already be in the memory, which means you can just start calling it and start working on it. And that is what I did is basically I just wrote data is equals to pd and dot read underscore csv. What is the address here? This dot dot means I'm in current directory, and then in the current directory I'm going to input folder, and inside the input folder because this is you can see what it looks like. This is the name, so this is the input folder, and inside the input folder this is the main folder. Then I went to the row traffic collision dataset, and then inside the row traffic collision I have two csv files. Right now I'm just accessing accident underscore data.csv. So that's what I wrote. What did I do? And when I did that, now I'm taking a look at the head, which means first five columns. If you want to take a look at more than five, you can just write a number here and it's going to show you more than five. So since it is restarted, I need to play it again. And let's run this. Since the data is pretty big, it's going to take some time. Give it some time. And please, anybody who's watching, please hit the like button. That would be really, really helpful for us. And so you can see now the data. So it is showing you 10 rows now instead of 5, because sometimes 5 rows are not enough. So what I do is sometimes I do 10 as well, or sometimes what I do is basically instead of doing 10, I can just do 5 here. And then what I can do is I can look at the tail as well. So I can go ahead and I can look at the tail, the bottom of the data set. And if I want to take a sneak peek somewhere in the middle or something, I can just take a sample out of it. Means I can do data.sample. Data is the name of my data frame that I set up here. This is the name of the data frame. And this is what I set up here. So this is the name of the dataset. And you can see that I can do sample as well. So this sample is going to take a sample of 10 random rows, which means those rows are not top, the bottom one, or anyone. Whenever you hit this again, it's going to give you a new dataset. So you can see the first value is nan here. This is unclassified. And if I'm going to take new sample, this is going to be a different thing. You can see this is not an unclassified. Yes, this is a nan, but this is not an unclassified. Okay, so you can do that. So what is the point of doing that? Take a look at the variables. What kind of a variables you have? Oh, I have a nan variable. But look at that. Sometimes you have nan variable and sometimes you have unclassified variable. Which means when I say unclassified, what does that mean? That means my data set has this particular column has a new category which is called unclassified. So which means nan values are also unclassified and unclassified is also unclassified. Technically, they are one and the same thing, which means I need to change this unclassified into nan, and I need to be very careful about it. Okay, and then you can see that this 9999.0 is a very big number. So maybe that is right, maybe that is reasonable, but you have to be very careful because sometimes arbitrary values are usually very big or very small, which are not usual. So when you do your EDA, you can take a look at that. Oh, does this 99999 make sense or not? Okay, so and so on. You look at all the columns, These are the days of the week, and this does make sense. This is the date. Then we have did police come to the party or not? Um, Accident, and all those things. Darkness, no extra, and take a look at all those things, and you will have a good idea. Right now, I'm not doing that deep pre-processing thing, so I'm gonna skip. The first step is always taking a look at the head, tail, and a sample of it, and then go through every column and get a feel of every column, what kind of variables it has. Then what you can do is you can look at the shape of the data. So when you look at the shape of the data, it's going to tell you how many rows you have and how many columns you have. And out of these 34 columns, you have one target column as well. In our case, our target column is usually the accident severity, I believe. This accident severity. This is our target column. Okay. If you want to make another target column, it's up to you. You can do that depending on your original goal of this particular project. You can decide which particular column should be your target column. Okay. Now we have already taken a look at the shape. Next thing I'm going to do is taking a look at the data type and null value count. So for that purpose, what I'm going to do is I'm going to do data.info. It's going to do both things for me. And over here, you can see every column I can see. So this is the number. When we looked at the shape 1048575, 1048575, all the columns which have this number, that means they have no missing values. But anywhere the number is different than this, like this one is a different one, which means it has a lot of missing values, about 50% I can see. This one has two missing values because this is 75, this is 73, everything else is the same. So most probably two. You don't need to count it, but I'm just guessing it. So this one has a lot of missing values. This one has missing values. This one does not have missing values. This one has some missing values, and so on. And then data type also tells you something. All the object columns are the categorical, can be categorical, because sometimes numbers or you can say number and strings can be mixed together. So mixed variables, pandas just consider it as an object. Object does not mean it is string 100% or number 100%. Sometimes it can be mixed as well. Okay. So when it is confused, it just gives it an object data type. Float are decimal numbers, and integer are whole numbers. Means positive or negative whole numbers, you can say. So, for example, like year column cannot be in decimal, but time column can be in decimal. Okay. So, but here you can see the time column is an object column, which means how come time can be an object column? So most probably what is happening over here is the time is 17:32, which means it is 5:32 p.m. And since it is separated by a colon, it is considering it to be not a number, a string. So what you can do is you can break that column into two different separate columns. One can be the hour and one can be the minute. So this way you can break down, and both of them can become a simple numerical column. Okay, so you can break it down then. So similar, so time can be done this way. Speed limit can be in decimals, but year cannot be. Means so that's why you can see it is integer, but it is not in float. But some things, for example, like pedestrian crossing or number of casualties, it should be integer. Means number of casualties can be one or two. It cannot be 1.5. Means 1.5 people got injured. No, either one person got injured or two-person got injured. I cannot say 1.5 person got injured. Who was the half person? We don't know. Okay. After we have done that, what we're going to do, so keep one thing in mind. Right now I'm just cramming through, but what you are supposed to do is you are supposed to take notes. You are supposed to take a complete notes on every column. Write down what is the null count, what is the data type. Keep recording as you keep on doing your analysis. You keep on updating that research thing. Okay, so you keep on updating the information for every column. So uh, then next thing what we're going to do is we're going to calculate the percentage of null values. So I've already written a code here. This code is doing what? Creating a new data frame. I'm calling it null underscore columns. Here I'm creating a data frame, and here I'm using my original data, and I'm gathering all the columns from my original data set. And then from those columns, I'm picking only the columns which have null value and any null value, and then I'm calculating all the null values from those particular columns, and I'm summing them, which means I'm calculating how many values are missing in every column of my data set. Okay, and I'm multiplying it by 100, dividing it by shape, which is the number of rows, which tells you the percentage. Okay, and I'm giving it a name. You can see the first column has 29% missing values, about 30,000 missing, 305,000 missing values, a pretty big number. I cannot do a complete case analysis on it. This one I can do a complete case analysis on it. This one I can do a complete case analysis on it. This one I can do a complete case analysis. This one I can do a complete case analysis. This one I can do. This one I can do. This one I can do. This one. Now keep one thing in mind. It looks like that this is 2, this is 29. All of these values, when you start dropping, they can start adding up, because maybe what is happening here is when you drop these 29 had values in it, which means when you drop these two are gone, then the next 29 are going to go, then next 269, next 111, which means if we start dropping all of these, it's going to be in thousands, which means you can drop some big chunk. So be very careful about it. So what you can do is you can also visualize the missingness as well. So here I'm using the missingno library. And why I'm using this library, not matplotlib, because in matplotlib I can do the same thing with the more lines of code than missingno. So missingno, one line of code is doing the job. So what I'm doing is I'm calling the mno function, missingno library, and then I'm calling a matrix function, and in the matrix I'm putting my data set. And keep one thing in mind, this missingno library works really well if your data set has less than 60 columns. If it has more than 60 columns, it does not work well. So what I do in that particular scenario is I basically grab only the columns which have missing values and then only plot those columns instead of plotting all of them. Over here, you can see that I have plotted all of them, even if they did not have any missing values. So what is the point of doing that? Because this tells you that whether the values are missing at the same level or not, because this shows you connection between two columns. Maybe those two columns are interconnected somehow. Okay, so maybe they are interconnected somehow. Okay, so okay, even though these guidelines are still on, but somehow bots can always reach these places. Okay. So I was talking about, let's quickly go talk about it. So this is missing no. So this gives you an idea. Right now, it is not giving me as much idea. So that's why I'm going to move to descriptive statistics. For descriptive statistics, I'm going to do for numerical separately, and I'm going to do for categorical separately. For numerical, when I'm going to do it, I'm going to be able to get these values. And these values are pretty important. Why? The one important thing that they give us is look at some variables here. So because uh, you can also remove some columns if their variability is zero. For example, if they have only one value throughout all the column, that means it is not changing, which means it is not bringing in any extra information, which means that particular column can be discarded. So over here you can see number of casualties. Minimum is 1, 25 percentile is 1, 50 percentile is this, 75, which means 75, more than 75% data is just 1, and then very few values, maximum value is this, which means you have to take a look at this column. How many categories does it have, and how many values are being because if it is just one or two or three or some few values, maybe those are the missing values technically. Then number of vehicles, the same thing. You can see minimum is one, then it is two, and 3.2. So this does make sense. This one you can see they're all 0, 0, 0, 0, and now this is value, which means almost 75% or more than 75% of the data is zero, but there are some values which are two. So maybe something is kind of like and similarly with this particular data. So you have to figure out variables which have kind of like, look at the variability for this one. The variability is pretty low here. For this one, it is not that low. For this one, it is pretty low. For this one, it is pretty low. Maybe if I can remove this column and that would be fine. But I have to check. Okay, so this one has a lot of variability. This one has good variability. This one has good variability. This one has good variability. These ones are tricky ones. Okay, now for categorical variables, when you do that, what I did is basically I did the same thing dot describe, but now here I'm doing include O. That means object function. So this way here it was giving me count, mean, standard deviation, minimum 25, 50, and 75 percentile, and maximum. Here it is only giving me the total count, the number of unique values, the top performer or the top frequent ones, and what is the frequency of the top one. Okay, so it is telling you about that. So accident index is something like this, which means you can see accident index, there are this many unique values, which means if there are this many unique values, then maybe we have data for the same accident for multiple vehicles. Means if two vehicles are involved in an accident, both of them are going to get the same accident index, but they will be different vehicles, right? So they will be considered at two different accidents. So that is maybe that is what is happening as well. So first road class, you can see it has only 5 different unique values, and A is the top one, and A is being repeated about 47,000 times. Similarly, second class, the same thing. Unclassified is the majority one, which means if you replace this unclassified with man, your man percentage is going to be so high here. Okay, so because this is 41,000 and it is already missing a lot of values, a lot of nan values, which means those nan values plus this unclassified values are technically more than you can say 800,000 values missing. So similarly, we can go through it. This one has days, does make sense, means it is several years of data, so it is a lot of days, does make sense. What these variables are, you need to read their detail. With to get the detail, you can read the data set details over here that I have mentioned. So you can read the description of these data set, and you can read that every column I have put in these information, so you can read every detail about it. Okay, so you would be fine. After that, we are going to check for duplicate, and if we want, we can drop duplicates as well. So this is data.duplicated.sum. It is just showing you the sum that there are 6 values which are repeated. But if I want to drop them, I can just do drop underscore duplicates. Okay, right now I'm not doing it. I'm just skipping to unique values. So let's count how many unique values we have. You can see these are unique values for every single column we have. Okay, for the integer and float ones, yes, you will have more unique values, which is fine. Handling missing values. Now let's talk about complete case analysis. Here, what we are going to do is we are going to drop values if they are less than a certain percentage, and then we are going to make a distribution of our data, original data, and the data where we have dropped the missing values, and we are going to see whether the distribution changed or not. If the distribution did not change, we are good with the complete case analysis and we can move on and handle other columns. But if not, then I'm not going to touch that column, and I'm going to put back all the values that I dropped in that column. So I'm not going to touch any column whose distribution is getting changed while doing the complete case analysis. So what I'm going to do is I'm going to grab all the columns here. When I'm going to grab it, you can see these are all the columns, and then what I'm going to do is I'm going to sample some of the columns from that data set. Not some of the columns, some of the rows using all those columns which have some missing values here. Then I'm going to do is I'm going to find the length of the data. So what I did over here is I basically dropped all the values which were less than 5% and more than 0%. So what I did is basically I dropped all the columns which had that value. So over here you can see that um, this column has less than 5%, this column has less than 5%, this column, this column, this column, this column, this. All these columns had less than 5%. What I did here is I dropped all the null values where the column has less than 5%. So which means I ended up with how much data still? About 96% of the data I still have it, which means I only dropped technically 4% of the data. Okay. Now what I'm gonna do is I'm gonna drop those columns which I have already done, and you can see the number of rows turned out to be from 1,048,000. It turns out to be 1,007,000, which means we dropped about 41,000 values. Okay, so which is fine. And here you can see that I got 30 from 34. I got 18 column as well. That means we dropped some columns as well from here. So, so technically what we are doing is we are doing the complete case analysis. We dropped all the rows which had any missing value less than 5%. And then we dropped all the columns which had more than 5% values missing. So we dropped all of them. So now we got rid of all those columns. So now we ended up with only 18 columns which have more than 5% of the data present, and more than 5% of the data present in the rows and in the columns both. Now I'm going to do this analysis on it. So when I plot all these remaining columns, their distribution is going to look like this. And now I'm going to make their distribution one by one. So for example, I picked first column, which was not the first one. I picked second row number. I could have picked first row number here. If I want, I can just replace it with first, and it's going to give me that. Maybe just do that. So what I'm going to do is first row number, let's change it to 1st and 1st. When I do that, you can see my new data frame is in green, and the old one is in red, and they are overlapped, and you don't see both of them separately. That means the distribution did not change, which means this column did well with the complete case analysis. Then I can change it to second one, and I can change this to second one, and I can see, oh, this also did not change. So this was histogram, but I can also make KDE plot as well, or density plot as well. So when I plot density plot for these ones, you can see the density plot, the red and green are also overlapped here. Very slight red you can see over here, but it is still visible. And then what I can do is I can do both of them side by side, and I can see what kind of. So for example, what I did is basically I created a data set or a data frame where I concatenated my original data set, the light condition column, and the new data set's light condition column. What you can do is you can change the column here, and you can look at the analysis, how much it is changed. So this one did not change as much. This one did not change as much. This one did not change as much. This one did not change as much, and this one did not change as much. So you can check for every column this way. And if you are taking notes for every single column, go and update that. Oh, this column did not change, this column did change, this column did not change, this column did change. So complete case analysis worked on this column and not on this column, on this column and not on this column, which means you did complete case analysis on all these, and you can do it for all these columns. I'm not going to do it for you. I'm going to leave it for you. You can work on it, and this is where I'm going to pick up in our next session. So I think that is it for this particular session. If anybody has any questions, please feel free to ask me, and I would be happy to answer. Other than that, thank you for sticking by with me, and uh, so we will do these kind of sessions every other day, Monday, Wednesday, Friday, until December. Okay, until the end of December. So if anybody has any questions, ask me. If not, then we're gonna finish up this session. I will be uploading the notes as well on GitHub as well. So if you go on GitHub, you can see that I did make a separate kind of like column for the notes as well. So what notes I'm taking here, I'm gonna print them out, means put them in PDF, and I'm gonna put those notes here so that if you want to keep track of those notes, you can do that. Yep. Thank you so much, Awais. I'm glad that it benefited you. Thank you, Lavanya, for the feedback. And it would be great if you guys spread around the word to any of your friends who are interested in these sessions. Just share the link. So I will create a link for the next session. I will share it on LinkedIn and on Slack as well. So if you can spread the word, that would be really really amazing. Okay. So I'm gonna close the session now. Have a good one. Bye bye.